And our next speaker, we've invited back, I think we try to invite Chris Holzapfel in about every second year. We trade off with him on, often he's requested to be at some Saskatchewan show this same week at the same time. So we're delighted that we have you again this year. And one of the questions that our committee, program committee came up with is, we just have too many questions right now on phosphorus. The 4 R's, some of the different sources that are out there, the rates of placement on things. Chris and his colleagues, researchers, Chris is based in Indian Head, but he has a network of researchers across Saskatchewan, and they've been tackling a number of these last few years. We haven't asked you to update us on it, but we're asking you here today. You've been the research manager there for almost 25 years, it says. You have your diploma from Olds, your degree from Lethbridge, and a master's from here. And we invite you here to bring us up to date with latest on phosphorus.
Right on. Yeah, always a real pleasure to be here. And if you think Alex had a lot of sides, you ain't seen nothing yet. But I do not feel so guilty about always yelling at my crew to get the hell off the field boundaries or stay in the field boundaries with the grain trucks after seeing some of that data as well. I know that's always an issue in our long-term plot land as well. We take management of that land very seriously, so good to see that. And I guess, yeah, on this topic here, Don called me back when I was still on the combine, and I initially agreed to a 25-minute presentation, I think, and then Curtis contacted me, said I had 45 minutes, and I was thinking, oh shit, I need to find some material here. And so I started getting a hold of everybody I could think of, send me what you got. And really, as I went through my own material and what people sent me, I realized that I had a lot and have done a fair bit of deleting and even left some reports out. So yeah, we'll go through some of it today, and hopefully you find it interesting. So just a little overview. We don't need to spend a lot of time. It's as much for me as it is for you, but we're going to spend a little bit of time talking about canola, some early just seed place versus sideband, pretty basic stuff. And then we did do some more elaborate work looking at all seed place fertilizer, but a few of the different formulations that are out there. And that's kind of what I was really asked to focus on today. So we'll try to as much as possible. Move into a little bit of our work with field peas, just kind of some classic fertility work. And then again, just recently here, we've been doing a little bit more with some different formulations there, seed place versus sideband. A little bit on flax, again, not honestly the new work there. I wanted to include it because I said I would, but the results aren't that interesting, so we'll probably buzz through it pretty quickly. And then I really do want to, I think, finish off with some I think more classic, long-term stuff, not necessarily my own work, but work that others have done that really just allow us to, have some broader thoughts on managing phosphorus and what's important and what isn't. So yeah, we'll get right into it, and I'll try not to hold up that poster session. So first, we're gonna go back all the way to 2016 here, 2016 to 18, and SAS Canola kind of rallied a few of us up just to really revisit recommendations for safe placed or recommendations for safety of seed placed fertilizer in canola. I think thinking that maybe some of the more classic recommendations were a little too conservative. People were struggling to get enough P down, especially if limited to seed placement. So just wanted to revisit it. We had 3 locations: Scott, Indian Head, and Melfort, all kind of focused on the dark brown and black soil zones, but some pretty diverse soil there. We, loam to clay loam texture. pH on Scott is usually quite low. They tend to be more sensitive to seed place fertilizer than we are at Indian Head or at Melfort. And then at Indian Head, we're, of course, a high pH non-calcareous soil for the most part, usually more moderate organic matter levels. We had 5 different phosphorus rates, 0 right up to 71 pounds actual P2O5 per acre, and then I call them placement options in air quotes because we do have sideband versus seed placed, all hole openers, so that probably will be important or something to at least bear in mind. But then with one treatment, basically just recognizing that some growers might be forced to do this depending on their equipment, we threw in 56 pounds an acre of ammonium sulfate just to put it down a modest amount of 13 pounds S per acre in the seed row. So yeah, just kind of a few highlights, I guess, from that here. This is, I left Melfort out of this. They tend to be more like Indian Head than like Scott, and I felt just really focusing on these averages from Indian Head and Scott kind of told the major picture. We actually did a lot of counts, 3 times in the spring, again in the fall, and it ended up being an overwhelming amount of data to digest. So this is just 4 weeks after seeding, some averages. And really what we see is actually at both locations, we are getting injury with seed place fertilizer. As one might expect, we don't always see that Indian head, but I always like to remember that we can, so don't push your luck. But I guess if we look at Indian Head first, or both sites, side banding was safe at all rates. At Indian Head in general, we started with higher plant populations, but we did reduce them, as you would expect, as we increased that rate of seed place P. If you look at the absolute numbers, we never really got all that low, though, and that's going to be important later. You know, we kind of bottom out at between 65 and 70 plants per square meter, so never to the point where we expect to have a negative impact on yield, but just, you know, bear that in mind if you're maybe pushing your seeding rates a little bit lower or dealing with some more suboptimal plant populations. At Scott, they started lower to begin with. As soon as they threw that ammonium sulfate into the seed row, right off the bat, they lost a fair number of plants, and then, you know, as they increased that rate of phosphorus, that kept going down, down, down as well. And it seemed like the ammonium sulfate maybe got less important at those high rates, but they were dropping things down to the impact or to the point where now we might be having some negative impact on yield there. And apologies, I will go through some of these fairly quickly. This is just a look at some fertilizer rate responses on yield that we had at the responsive sites. I should have pointed out we ought to go back a couple sites, but most of our soil test levels were a few low, a few moderate. When I say moderate, I'm kind of in that 15 to 20. And then Melford 2017, I want to say they had like 45 pounds or Olsen parts per million of phosphorus there. So that was one of our non-responsive sites, not surprising. We did have Indian Head 2016, wasn't responsive as well, despite low soil test P, but sometimes that happens with phosphorus. And these are our responsive sites here where we do see just some of the yield responses. They look fairly linear, but they're subtle, but they are there. Melfort 2016 would be kind of that more classic quadratic response. Scott, in 2 years, 2016 and 2018, we had this interaction, which was kind of interesting. So we plotted those separately, and what we see here is that pretty nice yield responses to side-banded phosphorus in these soils. But when we started putting that in the seed row, which, you know, we were just with toxicity there kind of doing is the damage we were causing was kind of offsetting, I guess, some of the benefits to pea fertility there. So despite the strong yield responses to side banding, you can see kind of a more flat or even negative response to increasing rates of seed place P, just at that soil there, just in that environment. And they are always our location where, you know, we seem to, if I want to get good information on differences between rates or formulations on crop establishment, Scott's a good site to work with for a lot of that. Looking into, I guess this is a new little demo that we actually did earlier, or not a new little demo, another little demo. It's actually older than the research that I just presented to you, but it was one that I kind of did on my own just through the ADOPT program that produced some interesting results that I think complement what we just looked at here. So here it was just 5 rates of MAP plus a control. We went all the way up to 89 pounds actual P2O5 per acre. Sulfur was kept non-limiting through just pre-seed broadcast of potassium sulfate. Sideband versus seed place, low residual P, about 5 parts per million. My land is, you know, mostly that 5 to 10 range. We do tend to be consistently quite low. And what I guess was unique about this year is we seeded into pretty good moisture, but then it was dry. We had really no substantial precipitation events until we were really into the 3rd week of June. That crop was ready to bolt pretty well at that point, and that's when we kind of got our first big rains. And then we had a lot of moisture, pretty good yield potential. And things went from there. So this is our establishment data, and you know, take this. I like to say don't try this at home. This was a year where we actually got away with everything under those conditions. We seeded into moisture, it was dry, but really no negative impact on establishment. I had farmers out at the field day that year who were working with mid-row band equipment, and you know, their eyes just lit up when we saw what we were getting away with. Like, wow, we can do this, and it was like, well, I guess we got away with it. Maybe, maybe not. So it is what it is, but you know, that's not something I would recommend, but you're gonna see that from time to time. This is what I really like to show you here, and this was actually the real classic pop-up effect to seed place fertilizer that we saw that year. So with our sideband, that's the green line there. You can see, yeah, a little bit of a boost in early season biomass production, But those seed place treatments really stood out, really jumped. You could pick out every plot, on the field day. And with the sideband, they didn't look all that much different from the control. And I don't really attribute this to distance of that fertilizer from the seed row, but I think it's more the dry conditions, banded with a couple 100 pounds of urea in there, maybe not enough moisture to get that urea to dissolve and move away from the band, and the roots just couldn't get in there. So I really have never repeated that response, at least not to that extent when we've had trials. And I've also seen pop-ups to sideband fertilizer. But this was a year where, seed place versus sideband, we really had that pop-up specifically with the seed placed. When it came to yield, nice responses, about a 15% yield increase with phosphorus. No difference between the two treatments. I also looked at maturity, really no difference in maturity. So once that moisture came, it kind of grew out of it and didn't really matter anymore. But it was interesting. Now we're moving into, I guess, some of the more recent work here where we really did focus more on some of the formulation. So in this case here, everything is seed placed for the phosphorus. We didn't seed place any sulfur unless it came with the other products. So we've got S15, of course, you're getting some in the seed row there. We had our pure struvite blend, no sulfur there. It was really just the S15. Everything else, we kept that out of the seed row. Three different rates plus a control. So 22, 40, or 58 pounds P2O5. We should be causing some damage with that 58 pounds, and more often than not we do, you'll see. Our forms were just the classic 1152, S15, crystal green pearl, or struvite, we'll call it for our sake here, or just a 50-50 physical blend of MAP plus struvite. And again, this is all put in the seed row. If you look at our chart there to the right, you can see our Olsen P levels were pretty low right across the board. We range from, I think on the low end, 6 parts per million. We have one site over 15, which is just at 16. So all in all, quite low residual P in this case. Whole range of soil organic matter and pH. Looking first at emergence, don't bother yourself too much with all these statistics. I don't expect you to read it. I'll give you the highlights. No treatment effects whatsoever at 36% of the sites. So 5 out of 14 sites where we did this work. I forgot to talk about sites, but we did have, kind of more or less over a 3-year period, locations all over Saskatchewan. So it really is quite broad data, if you will, in that regard. But no response, 36% of the sites. Generally, your moderate organic matter, fine textured soil sites, usually better moisture on average, maybe not every year. Phosphorus form affected emergence 64% of the time, so at 9 of our 14 sites. And of those 9, we basically had interactions between rate and form 78% of the time. So that's a little bit of what we'll look at here next. So just of our responsive sites, this is basically what we see for the form effects. And it's pretty much what you'd expect and probably what you've seen based on some other work generated in Manitoba here, where it's really just showing that seed safety benefit of the struvite in particular. You put that in a blend, maybe you lose a little bit of that, but it is a product where if you, for whatever reason, want to get all that fertilizer in the seed row, it's going to be one that you can do so quite safely. We'll look at some individual site data. So I talked about Scott earlier being a good site to pick up such treatment effects, and these are just our 3-year averages. I didn't actually analyze it this way, but I do give you the individual site statistics there, but things were pretty consistent, so I think this tells the story. Where with struvite, we essentially had no impact on emergence whatsoever at Scott. With that blend, things a little bit more intermediate, but by and large, not much impact. And then the MAP and the ammonium sulfate, MAP and S15, substantially more injury at that location. Looking at Indian Head, well, with these rates and those years, didn't much matter. All forms were all the same, and we got away with it. We weren't getting real wild with our rates, but it just didn't matter a heck of a lot there. I'm probably going faster than I need to. I'm so used to being behind time. So here are just our overall averaged form by rate interaction. So this is the average of 14 sites all over the province, geographies ranging from Swift Current to Melfort. Not significant in all cases, but these are just the averages that we are looking at here, and I do think it kind of just gives you a nice broad picture. Again, struvite, no impact on emergence whatsoever. The blend is a small impact. It is a linear response there, but certainly looks a lot better than either the MAP or the S15. I also present to you, just if you look on the far right-hand side there, our overall averages for each fertilizer type. And there actually had separation between every single product. I don't include the control in this particular analysis. This was a weird just treatment structure to analyze. I wanted to use the factorial analysis, but basically our best product, of course, for seed safety, struvite at 75 plants per square meter, knocked off a few plants down to 70 plants per square meter with that blend. With MAP, we dropped down to 64 plants per square meter, so again, a fairly substantial drop there. And S15, just a little bit worse than MAP, which is really exactly what you'd expect. I think in the early days of S15, you'd sometimes hear of it being a safer alternative, but that was always using the assumption that you're basically making an equivalent blend of MAP plus ammonium sulfate. If you don't need that sulfur in the seed row, of course, the MAP's going to be a little bit less hot. So yeah, that's our overall average results. Things cleaned up quite nicely. The individual site data wasn't always that neat, but that's the way it goes. Looking at yield here now, again, don't worry about the real busy chart there, but any statisticians who want to press pause on the recording later can have a closer look. No treatment effects on yield whatsoever at 36% of our sites again in this case, so just no response to P despite relatively low soil test P. It does happen. Form only affected yield at 3 out of 14 sites, and of those 3 sites, basically we did have interactions in all cases, and rate by form interactions were frequently detected, but in some cases they were either really subtle or there was a couple where they just seemed to be kind of more noise than anything, pretty random. So here's our overall yield responses to phosphorus. So this is actually just a very simple check versus rest. No P applied versus P applied, and it just kind of shows you how we have, I guess, for 64% of our sites, they have a star there. So actually, if there's 1 star, that means only a 90% probability. So p-value of 10%, which I think is okay for something like this. Some cases, the response was pretty strong. Some places, it was pretty small. Some cases, it wasn't there at all. Never negative, but again, that's pretty classic for phosphorus. So where did form matter? Well, it was really just kind of in these 3 cases right here. And 2 of them were Melfort, and I don't really know what it is specifically about this site, but we had basically a poorer response to the pure struvite at Melfort in these years. The blend, worked out quite well. MAP, S15, all equivalent, but for whatever reason at those 2 locations, pure struvite just wasn't as soluble. The plants didn't take it quite up as well. We do have pretty good yield responses. And then at Swift Current 2022, we also had a little bit of a benefit to S15 over the other products there, which that's something I see occasionally. I don't show you a lot of that, but we do have data to show that it happens from time to time. These are just our interactions. They don't really add a lot to the pure form effects. So this is Melfort 2021, where it's really kind of what I've already shown you, where we just see with that pure struvite almost no response. Those are the green triangles down at the bottom. The blend looks okay, but not quite as good as our S15 or MAP. When we went to the next year at Melfort, things looked a little different. Again, pure struvite, it really didn't respond to it. But here we actually see some negative impacts to that very high rate of S15, maybe just getting a little bit hot at that higher rate there. The blend, the other products all performed pretty equally for the most part. These are our overall averaged, 14 site effects on yield here, and it looks, a lot, kind of like what we saw at Melfort there, not quite as subtle. Again, really bear in mind that results do vary from year to year, but this is our 14 site average. So the control's not included in here, but if I do include that, we are getting an overall average response to phosphorus. It's not huge, but it's there. MAP S15 and that MAP struvite blend all produced similar yields. Everything was within about 2 bushels of each other. It was just that pure struvite that showed up. Melfort was the only location where that really popped, being significant. We did see the trend for it in kind of a few other cases though too, which helped drive these yields. But in many cases though, it was performing basically equally. This is something I wanted to share here, just some emergence data, but this is actually just some industry work we did back in 2021 looking at top phos. I know that's something that people are probably interested in. I would like to get it into more public trials, but this is a product that I don't know a lot about it. I think some humic and fulvic acids maybe go into the manufacturing process, but it is marketed as something that's supposed to be a better candidate for in-furrow placement than maybe some of our classic pea fertilizers. And when we looked at this emergence data here, that's certainly, I think, would support that. We see pretty good separation, especially at those higher rates between the top phos and the MAP, so a lot safer on the crop for emergence. One little caveat here is we actually kept sulfur balanced in all treatments, so we applied enough sulfur as we were getting at the highest rate of top phos, and that all went in the seed row. So lower rates of top phos got a little bit of ammonium sulfate, all the MAP got ammonium sulfate at, about 56 pounds an acre of actual product, I guess. So that's causing some of that separation, but all in all, it looks good. And I don't present the yield data, but this was a year where, despite relatively low soil test P, we actually had no response to phosphorus whatsoever. So whether it was MAP or the other product, they were all basically just the same as the control. All right, so I guess moving on a little bit to field peas, and again, I'll have to try to slow down a little bit. So I think I'm going faster than I thought, but that's okay because I have bonus slides at the end that I didn't think I'd get to present. So. And sometimes when I think I'm ahead of time, I start slowing down. Next thing you know, I'm out of time. So we don't want to get too carried away. Just to open things up, I guess, for some of our P work. This is just really some work that we did it was kind of commissioned by SAS Pulse back in 2019-20, and really just wanted to revisit the whole fertility package for field peas. So worked with basically almost the full Agri-ARM network that John touched on there. We've got sites at Swift Current in the dry brown soil zone. Outlook is a brown soil zone site, but irrigated. We've got Scott up in the northwest, presented lots of data from Scott already. Indian Head, of course, where I'm at. Yorkton, usually things are, I would say, fairly similar to Indian Head in a lot of respects, maybe a little bit more variable up there than what we have on our land, not as quite a heavy clay content of a soil. And then Melford, which is, again, getting into the really high organic matter, also a clay soil. But our treatments are busy, but we kind of set them up in a manner where we could isolate responses to each of these nutrients. And we basically got our no fertilizer control right at the top. Another treatment where we just, basically we call it a 0P treatment, but we gave it a little bit of sulfur, and we also added 15 pounds an acre of nitrogen, really just to kind of try to keep nitrogen balanced across most of those other treatments. Then we have a whole series of phosphorus rates where it was either 18, 36, 53, or 71 pounds an acre, actual P2O5. This is all side banded, by the way. We didn't seed place any fertilizer in this case. We tested responses to sulfur where all the other nutrients were non-limiting, and then we also had some nitrogen treatments that I'm not going to get into, but if you have questions, I can try to answer them. A little bit of broadcast urea. I'm trying to basically not have that negative impact on nodulation, but throwing in some nitrogen for later in the season. Also somewhere we use DSN for a similar purpose, and then kind of an ultra-high fertility package is what we have at the very bottom there, where we use the big rate of P. There's lots of nitrogen there, some of them, for the most part, coming with some of the other products, but added a little bit extra, and some of that nitrogen is ESN and the big rate of sulfur. Looking at our data, we can see really, I think what's interesting, if you kind of drill in on the left-hand side of that response, that big scaling up, that's all phosphorus response right there. So I guess just to convince you that field peas can respond to phosphorus, this was our overall 12 location average. Went from 62 up to about 67 bushels an acre with the addition of P fertilizer. When it came to individual sites, there was some variation there, which I guess I don't have the specifics. I want to say 7 out of 9 of our low P sites responded to P, if I remember correctly off the top of my head. We did have a couple high P sites that did not respond, which I'll touch on that. Or higher soil test. Actually, no, just the one. I think the only one I classified as high soil test P was Outlook 2020. I show that on the left-hand side where we had 24 parts per million. So not crazy high, but to the extent where you don't necessarily need to be thinking about building your soil test results. But yeah, a lot of what we're seeing there is really just the response to phosphorus. We see a check versus fertilizer response. Extra nitrogen did nothing for us. Linear and quadratic, if I have both, I usually give more credence to the quadratic response to phosphorus. Sulfur did nothing for us either way there on these particular soils. So, well, that's actually a lot of soils. This is just our overall 12-site average response to phosphorus. And then I throw in the results from Outlook, really just to, I guess, give a little bit of a plug for soil testing is kind of why I decided to include those individual site results. And this is a site where in 2019 we had 5 parts per million Olsen P, so very low. The data was a little bit messy, but you can see kind of a pretty big pop right off the bat when we just put a little bit of P there, and it was linear according to my contrast, but that was kind of just because it was a bit messy. Then the same land, that 24 parts per million, or the same general geography anyways, no response to P whatsoever. So that's really just there to, say, there is some value to these soil tests, which I think this room probably knows, but nice to sometimes see data to support that. Getting into our, I guess, newer research here that's just kind of underway this year. This is something I actually just ran this, or I initiated it through the ADOPT program, so it's purely funded through ADOPT, something that I was interested in just to test some of these different forms. So really we've got, I guess, a range of phosphorus forms plus some ammonium sulfate in the mix. So if we look at that first, we've got MAP plus ammonium sulfate, just to kind of get that in there and see if we see any response to the sulfur. S15 is just kind of a classic product with, I should have had the numbers handy, but it does have a quite substantial market share actually of the phosphorus market. And then we have Synchro 50 in there, and I threw in a little bit of ammonium sulfate anyways. But for those of you who aren't aware, I guess Synchro 50 is a crystal green product. So it is very much like a physical blend of 50% struvite by mass, 50% crystal green pearl. But they've kind of made this product for you. What's unique about it, I guess, is that both forms of phosphorus are equally homogenized within every granule. And I suppose the other thing is they have done the blending for you. Sometimes you might have to buy that stuff directly from Taurus, so it could be a little bit awkward to try to do your own physical blend, so they've kind of taken care of it for you, I guess. So I was originally just going to do the physical blend, but one of our reps from Taurus said, hey, well, we actually sell way more of this, and it's kind of the same thing, so we decided to swap it out. Then I have a 0 fertilizer whatsoever check and a nitrogen only check where we wanted to just see if we're getting a little bit of benefit to that nitrogen. All those P forms and S, I guess, if you want to conclude that, were both placed in furrow and side banded. We ran this at 4 locations, Indian Head, Melfort, Scott, and Swift Current. I like that for seed safety work because Scott and Swift Current are both kind of our more sensitive sites. Indian Head and Melfort are kind of the 2 where we can get away with a lot. So that's a nice kind of, I guess, selection there. Plant density, of course, is important. Rather than doing biomass, we did some canopy closure measurements with the Canopia app, yield and protein. And I'm not going to show you all the data, and I will probably be reanalyzing this, trying to figure it out, but really I just wanted to get stuff ready for you today. So first, Indian Head, focusing on establishment. Here's our field P establishment. Really, it didn't matter. Again, I've kind of beaten this into you, but Indian Head, we got away with a lot. None of this mattered. Importantly, and I didn't mention this, all of the phosphorus fertilizer was applied at 40 pounds actual P2O5. We didn't have rates, but we did choose a rate that we thought was typical, pretty, much what you would want to apply to match replacement, but also high enough to probably cause some injury. Here at Melfort, things were a little bit messy, but we did see, I suppose, just an overall difference between sideband versus in-furrow placement. Not really too much, I think the data was just too variable to pick up real differences between individual forms. Maybe appeared that the MAP plus MST and Synchro 50 were similar. I forgot to talk about MAP plus MST. I don't know if you guys are aware of that product, but it's actually just kind of a way of getting sulfur to your crop. But it's just monoammonium phosphate with micronized elemental sulfur homogenized within the blend. We were using it as a phosphorus form because there is some data suggesting maybe a little bit better uptake with that relative to just traditional MAP. So we wanted to just test that out. Swift Current, quite a bit more injury, I guess, with that seed place fertilizer there, particularly with the MAP plus ammonium sulfate, the S15, also the MAP. Looks like our Synchro 50, every product except for the MAP plus MST, that might just be kind of noise. We were causing a little bit of injury. Comes to canopy closure, this is just a little bit of a look at what the software is actually doing, but we just take overhead photos of the crop, run it through some software, it tells us % canopy closure. So that's just kind of a look at some of it from Indian Head. When I look at our data at Indian Head, we see an overall kind of early season growth response to phosphorus. Not much difference between the forms, with at least nothing statistically significant, with the exception that sideband at Synchro 50, for whatever reason, seemed a little bit poorer. But I wouldn't weigh too heavily on that. This kind of data can sometimes be pretty messy and doesn't always mean a heck of a lot. The crop could grow out of it later on. Not much going on at Melfort with this measurement. And Swift Current, the only thing that really popped was that side-banded S15, but again, I don't know if that's more just kind of background variation or a true effect, so I wouldn't get too hung up on that, but just figured I would share it with you. Looking at some of our yield responses, this is what we saw at Indian Head, so very nice yields at Indian Head for our field peas this year. We were up, pushing 90 bushels an acre with some of these treatments. We do have an overall response to phosphorus. It is fairly small but significant, at least with some of my contrasts. You see a bunch of A's there, but when I did kind of use, compare groups of treatments, some of this started to pop. So we did have a small but significant response, but really, when I compared individual forms within that, all of the forms, none of them differed from each other when it came to the yields that we achieved at the end. So all performed quite well, and no difference between sideband versus seed placement when it came to yield either. Melfort looked like some trends there, but the data was just kind of too variable for anything to be significant. But yeah, we'll just kind of leave it at that. Maybe something will come up when I clean up the data a little more and try some more powerful analyses. Swift Current, we do see, I guess, looks like kind of somewhat unexpectedly, we do have a pretty good overall response to phosphorus, but the in-furrow actually yielded a little bit higher than the map. Okay, we're getting a warning here. I thought I was overtime. And yeah, so we'll move on to flax, and actually the new data isn't very interesting at all, so that's okay. I'll just show you a little bit of kind of our classic work, and this goes back to 16 and 18. Really extensive research. We ran this at, I think I ended up with up to about 18, 19 site years, looking at nitrogen and phosphorus responses in flax. I show you this emergence data just because it's interesting and it shows how sensitive flax can be to fertilizer, period. This was actually all side-banded, but even with side-banding, we were having a significant reduction in flax plant stands with the high rates of nitrogen. It didn't happen every soil, but it happened on average, and it happened quite frequently. MAP really didn't matter. If we were putting that into the seed row, could have been a different story, but we tend not to do that in flax, just because I think we know that that's such a sensitive crop. When it came to yields, yes, we do in fact have pretty decent responses to phosphorus fertilization. That interaction just shows that we need to take care of the nitrogen first, though. If nitrogen is limiting, we're not getting that response to phosphorus. Here's my new work, really just to kind of show you what we're doing, I suppose, as much as anything. Not so much that it's very interesting results, because there's essentially no significant results here. But what we were doing was looking at a few different biological inoculants that we thought might have potential, or at least be marketed to affect nutrient uptake in flax. So we've got our untreated, good old Jumpstart there, and then AgTiv Reach, which is an AMF inoculant, and then a few different forms. So no P fertilizer whatsoever, 1152, S15, or MAP plus MST again. In this case here, sulfur was balanced across all treatments with ammonium sulfate where necessary, or at least close to it. But yeah, really no responses this year. Our tissue P, it looked like we had a little bit of an effect, just a P fertilizer. If anything, the MAP plus ammonium sulfate, so just MAP essentially, was giving us the best results, but no statistically significant difference between the forms there with P uptake. And I couldn't get any response to yield. It looked like we had some trends there, but nothing was significant. Yields weren't, that's total P uptake, sorry. No significant difference there, but yield, yeah, same thing. No significant response to yield. Yields for flax weren't quite where I wanted them to be this year, but still about 30 bushels an acre. We did this at Yorkton. There's our sites for that. Nothing popped out there. We also did it at Melfort and Scott, but we lost those sites due to some herbicide application errors. Moving into, I guess I don't have the capacity to do work with in-furrow or putting liquid fertilizers down through our drills. So this is some classic work done here at the University of Manitoba by T-Bone Go, Rigas Karamanos, and John Lee with AgBies, where basically they just took these different forms, so either MAP or ammonium orthophosphate, two different types, or ammonium polyphosphate, put it in the soil, and then measured both orthophosphate or soluble P and Olsen P for an extended period after application. And really what they found is that initially upon application, the liquid forms of P were always more available, But by 2 to 4 days, depending on the soil, you know, it really didn't matter. All of them were pretty much equivalent in terms of what those forms of P were in the soil. This was their most sensitive, I guess, or where it mattered the most, and that was an alkaline, non-calcareous soil. But even there, I think by 4 days, there were no statistically significant differences. So I think long story short is that, you know, just your more traditional approaches can be equally available under normal field conditions in Western Canada anyways. This is really supported by that, or supports that. This is just some work by Cindy Grant, done over 3 years at 2 sites near Brandon, showing that MAP and ammonium polyphosphate are producing the exact same yields. This slide I like. It's some older data, but you know, running over quite a long period from 1967 to 1995, really just showing how variable the response to phosphorus can be on a single soil type. And you know, I guess I like to show this because it does support some of our own data, but I think there's also just some stronger messages there. You know, it does create some challenges for phosphorus research, especially when we're just doing these little trials, you know, 1 year here, 1 year there, one site there, because your responses can be all over the place, even on the same soil as we see here. And I guess the other thing I take from this is, you know, just be critical sometimes, because it can be pretty easy to produce misleading data. I might go over that, John, but I'm moving fast. It can be quite easily to produce misleading data that is showing that, I guess, you know, maybe some less sustainable approaches to P management are producing results that are just as good as, you know, the more classic maintenance basis approaches, just because that response is so variable and you don't always get it. So, you know, when you try fine tuning that, things can change. Just kind of showing, I guess, what mining that soil over a long period of time can do. This is from the long-term rotation trials at Indian Head. The blue bar would be full nitrogen and phosphorus fertility over that full period. The very bottom line, without any, I guess, a red arrow, is just no fertilizer whatsoever. That red one has a green manure 1 year of every 2. So I'm not going to say that green manure is replacing all the nitrogen, but it's replacing a decent percentage of it. So we can, you know, I guess, deduct that, you know, at least a good chunk of that gap is related to mining out phosphorus fertilizer over all those years. Some work from Saskatoon really just showing that, I suppose, residual P does matter. You know, even with real low residual P, even when you do apply P, you can't always make up that yield gap. And high P soils can still benefit from starter applications of phosphorus as well. So I would never really say 0 P is appropriate.
Question about that.
Sure.
What if you have like 80 parts per million?
Yeah, I don't ever see that, but you know, that might.
Yours has a lot to cover.
Not too much, but I'd be tempted to still put a tiny amount down, but it's not. I haven't seen a lot of data to support that one way or another. But yeah, there you're getting big. This I want to share though. This is pretty exciting. I think a lot of you have probably seen Adam Gurr's long-term P loading trial, and he was kind enough to actually update to us to bring us right up to 2025 for this project here. So basically, back in 2018. He had a low soil test low soil test site, and he either front-loaded that with 364 pounds actual P2O5 per acre, 700 pounds an acre of MAP, cut that in half, so 182 pounds P2O5 per acre, or went in with a variable rate application that was, I think it was Crop Pro did up the prescription for them there based on swap maps. So some of you might be using those. But really what this is showing us is some, you know, big gains initially to that P loading. We're getting some big yield gains. Everything after this did get a starter application of 35, I want to say 30 or 35 pounds P2O5 per acre. So we were always applying P every year. This is just a response to that background P. And it really carries through almost every single year that he's measured yield since. There's been a few where maybe other factors were more limiting to yield. But even you know, now here in 2025, some pretty big gains, and the variable rate is really standing out. In that variable rate application, they applied about 140 pounds actual P2O5 per acre compared to 182 or 364 in the other treatments. So lower rate overall, but redistributed to where they needed it. So I really like this data. I think it's, I've always thought that there's a good case for variable rate and precision ag with phosphorus because it's so stable, and I think this data really supports that. Adam went back and redid the economics here. So over an 8-year period, he bought that map for $580 per metric ton. I bet you wish you could get that now. And it, obviously looked really good, strong returns on investment right across the board. The variable rate was by far the best. But we actually went back and said, what about 1,200 pound an acre MAP or 1,175? And actually after 8 years, we're still dollars ahead for every single one of those treatments. It's tight with that really, heavy front load there, but regardless, this is return on investment. So basically for every dollar spent, he's gotten back over 8 years, $2.50 back with that variable rate application. Just a little bit to think out, I guess, on, this is all coming from Fran Wally's work. John presented some of this with the nutrient removal calculator, just showing you, what kind of yields are you trying to achieve. Anyone can look this up and calculate their yields. This, I think, is important. It is actually just, what are the costs of the different phosphorus forms out there? So actually, I had Danny, our manager, he went and made some calls back on November 28th and got prices for all of these different products. I went and figured out, basically assigned some value to the nitrogen and sulfur coming from those. The highlighted numbers are dollars per pound P2O5 after accounting for the nitrogen and sulfur coming from those products. So just goes to show, I guess, what some of these are costing to bear that in mind. My take-home messages, so recommendations for safe rates of seed place P, at least in Saskatchewan, I'm less familiar with Manitoba, do err on the conservative side. However, the actual safe rates vary very widely with soil, crop type, weather, form of phosphorus, or other products in that blend. So, there's a reason that they're conservative, and I suppose if you want to push that, just maybe pay attention to what negative impact you might be having and just be aware. Advantages to seed placement relative to side banding can occur. I've had a small handful of cases where that can happen. Rarely result in real yield differences, but sometimes we see that pop-up effect. And side banding is a safe, effective option. At high rates or with sensitive crops, it's more common to see the advantage of side band placement based on our data. Aggressive approaches to P loading to build up low P soils can be both effective and economical. Maybe less viable at current fertilizer prices, but Adam's analysis showed that he's still coming out dollars ahead, which was actually quite surprising for me. Excellent use of and opportunity for variable rate applications, I think. Novel P forms are often advantageous with respect to seed safety, handling, how many carts you have in that drill, just how they behave with storage and humidity, things like that. So there are lots of advantages. That being said, over the long run and in general, I think the best product is the one that you can afford to apply at sufficient rates to maintain or build soil fertility, especially if you have a soil where you need that. So just bear that in mind. And I always like to think that I'm not only fertilizing the crop, but also the soil, and probably more so the soil when it comes to phosphorus. And that's all. I do have some bonus slides, but John's not going to let me get into those ones. And we don't really need to. Basically, it was just I had some showing with elemental sulfur. I know John likes this here. Basically showing in our environment with elemental sulfur, it can work, but it takes time. So if you are relying on that in an S-deficient soil, you just need to be aware of that. A little bit on every acre, every year is kind of the way I would like to look at that, because with us over a 2-year period, first year we almost took up no elemental sulfur from an S15 product. Second year we were starting to take up some more there. This is just a little one I threw together for soybeans there, but just basically showing that in Saskatchewan we can get a response to starter P with soybeans. So yeah, I would go ahead and put some down. Be careful with the seed safety. We're going right up to 40 pounds an acre without much injury, but once we push beyond that, it gets a little dicey and we're having some negative impacts. And now I'm really done. Sorry, John.
Yeah, you're just teasing us with all this good stuff at the end. Thank you very much, Chris. We'll thank him first, and then I'm going to pose questions. So, any questions from the crew? Now's your chance, Elizabeth.
No, I interested.
Oh, no, but not everyone else heard you.
Okay. So we work with a lot of farms that have manure,
Yeah.
and we're always trying to draw down. So what do you tell those guys on the off years where they're not in the manure years? They can't be putting on phosphorus when we're trying to draw it down.
I think what you could maybe do is, honestly, more often than not, you're probably not going to see a response. If you really wanted to be safe and to make sure you didn't even maybe 10 pounds P2O5, something like that, you are still going to draw, but
The whole tank, though, that you gotta have.
yeah. Yeah, and it's kind of a pain in the butt to throw in a check strip with something like that as well. I realize that that's not always easy. And I don't know if anyone else has any thoughts on that. I feel like you'd get away with it, more often than not. We do look at some of these trials here, but we're not dealing with those kind of numbers either, where we do see the benefit to starter P. These are averages. A lot of years you probably aren't getting that, but on average, you do. Some of it starts to pop, but yeah, I don't think you're going to. Any thoughts on that, on a manured field with extreme levels?
Go naked.
Yeah, nothing.
Those people that have posters, hustle your butt up here. Your chance is now, and we have a chance for one more question. From online?
Maybe. Here we go. Have you been able to pinpoint conditions, say soil, environmental, biological, that are common in the fields that were not showing P responses when it was expected based on soil test values?
Not necessarily. I mean, I think soil testing and just that residual P gets us close, but you don't always see the results you'd expect. So like I said, sometimes we see responses in high P soils. I have lots of cases with low P soils where we don't get that. Most of our land is long-term no-till. At Indian Head, we're 4 to 6% organic matter. Canola, we're often seeding a little bit later in May, so things are warming up, starting to cycle there. So, I guess sometimes we might underestimate what the environment can provide. Not uncommon for me to grow 45 bushel an acre plus canola with no P fertilizer, so it's obviously coming from somewhere. But no, I wouldn't say it's difficult to pinpoint. There's just so many different variables there. And soil testing gets us close, but it is imperfect. I think soil sampling, the real value is monitoring how your management is impacting that soil fertility over the long run, more for kind of like a report card, but also, helping predict response.
Well, wonderful. Continue producing such great practical data for us, Chris, and join me again in thanking him.